Hello and welcome to my YouTube channel, Living an Unlived Life. This is the 9th video in my Mindset Reset Challenge series, which came about when, in late 2024, I decided to radically change my life by making not one, but a massive 52 New Year's resolutions. If this is the first time you've watched one of my videos, you can find the introduction to this series here. In this week's activity, I challenged myself to make a 3D printed cover shell for 2 of my drones, neither of which had come with protective cases, and I hadn't found anything available online that suited my purpose. My small drone, a DJI Mini 2, came in a flimsy plastic bag that I lost long ago, and it's very fiddly trying to keep the propeller blades together while I'm putting it back into my camera case. While my big DJI Mavic 3 Pro came with a harness system to keep the blades together and protect the gimbal, this is also very fiddly, and having a plastic case for it would make handling the drone much easier and safer when getting it in and out of its shoulder bag. However, I know absolutely nothing about 3D printing, so this challenge will be one where I'm starting from the very beginning, and it definitely seems like there's a lot to learn with printers and software. The obvious place for me to start was with some online research on how 3D printing worked and what sort of 3D printers were available that would be appropriate for this sort of construction. After a few hours surfing the net, I came up with the following summary. Technically known as additive manufacturing, the best way to understand 3D printing is to think of an inkjet printer where, instead of the ink being written down the page, it writes sideways using either melted plastic, molten metal or cement, and then adds cross-section layers upwards which fuse together. 3D printing arose out of CAD/CAM, which became widespread in manufacturing industries in the early 1980s. While 3D printing was developed about that time, it didn't become available for personal use until about 2005 with the launch of the RepRap project. Even then, it didn't become popular for home use until about 2010, when affordable printers started to come onto the market. However, even now, it is still largely a hobbyist and small business activity, with the majority of dedicated users being people who've found a niche printing specialty parts to sell online through a home-based business. 3D printers range in price from about $300 for simple models suitable for amateurs up to $10,000 for professional desktop models suitable for people running a home business. There's a very large number of brands of 3D printers which vary greatly in terms of functionality. One of the most important factors in selecting a 3D printer is its ability to produce very thin layers, which results in a smoother product. Printer speed is probably less important to the home user than ease of use, software connectivity, reliability, durability, safety, and quietness of operation. The build volume is also important, with most home printers only able to produce small objects, and here I realized that I had a problem. With all the printers that I had looked at, the plate that the object is built on was going to be too small to build a case large enough for my Mavic 3 drone, though I could probably build one for my Mini 2 drone. What I needed to understand next was the materials component of 3D printing. When I started to read about 3D printing materials, things got complicated. All of a sudden I was reading about filaments and resin and wash and cure machines. So I went to a local electronics store and talked to an assistant who explained that there's 2 main types of 3D printers, those that use plastic filament and those that use liquid photopolymer resin. Filament printers are cheaper and easier to use, especially in terms of swapping print colors. Liquid resin printers are more expensive, but the quality is much higher. Filament printers are better and more versatile for larger objects, while resin printers are ideal for the high precision and intricate detail needed for small objects, such as gaming miniatures, which have fine relief and need very smooth finishes. However, because the resin is toxic, the printed object must be washed and then cured with UV light in a separate machine before it can be used. So it quickly became clear that what I needed as a beginner was a filament printer. However, having made that decision, I discovered that there's many different types of filaments which vary considerably in properties such as print temperature range, strength and flexibility, adhesion, toxicity of fumes, and post-processing needs. The most popular filament for newbies seemed to be PLA, which is cheap and easy to use. It has a low melting point and high rigidity, but degrades quickly in the sun, so it's only good for decorative items, toys, and indoor functional parts that are not going to be used in extreme conditions. A tougher alternative is PETG, which has medium strength and durability and only needs a low temperature to print. While it is heat and UV resistant, it still has some quirks, such as stringing out and becoming brittle if printed too cold. ABS is tough and long-lasting and good for parts under sustained stress, but it needs higher temperatures to print. A step up is ASA, which has less fumes than ABS, plus is durable and has UV resistance, making it suitable for outdoor use. And finally, TPU is good for anything that needs flexibility. My next step was to work out what 3D printing software to use and then learn how to use it. A shop assistant at the JCar store had recommended that the website Tinkercad was a good place for a novice to start. Then another person suggested that Thingiverse would be the best option for me at this stage. Both websites have vast repositories of 3D model designs ready to be downloaded to print, although if I couldn't find a design for the drone covers I wanted, I would need to find some software that would enable me to construct my own 3D models. But for the moment, looking at these two websites made me think that this challenge was going to be a lot of fun, even if I didn't ever get my Mavic 3 drone cover constructed. Now I just needed a printer to play with. In terms of obtaining a 3D printer, there were two options: buying one online, which might be cheaper, or buying one from a bricks and mortar store. Because I was in a hurry, I decided to get one from a local electronics shop. However, being a specialty item, there's not many places that sell 3D printers in my hometown of Canberra. When I asked Google Maps, where can I buy a 3D printer, the map gave me mostly sites where home-based businesses offered their 3D printing services. There was, however, one business with 3 locations citywide that sold 3D printers. But then, after I was bedazzled with options at JCar, a friend mentioned that he had a spare printer, and before I knew it, he delivered it to my place, so I had no choice but to get started with unboxing and setting it up. The 3D printer that I had been given was a Creality Ender 3 V2 Neo. Creality is a Chinese company that makes a range of 3D printers suitable for hobbyists, small businesses, and 3D print farms. The Ender series of filament printers is popular because it is relatively affordable, reliable, and very quiet. Plus, with only a few large parts, it's easy to put together. An additional attraction is that the build plate has a thin, flexible magnetic sheet on top so that printed items can more easily and more safely be removed. While the box contained a quick start manual and the enclosed SD card contained both a PDF manual and a video, in the end I followed a comprehensive unboxing and setup YouTube guide that had been created for exactly this printer by Just Vlad, which helped me put the printer together with way less trouble than I would have had otherwise. After attaching the gantry to the print bed and all the wires were connected, there was a complicated process for levelling the build plate and positioning the print head. But with this done and the filament fed through to the extruder nozzle, I was finally ready to print. The software provided with the Creality printer also included 2 sample items to print, a rabbit and a small boat, so I commissioned the boat. While it took 2 hours to construct, I was elated. I'd completed the first part of my 3D printing challenge. My cute little boat had been easy to print because the file for its construction was included on the SD card which came with the printer. But now it was time for me to learn how to print objects downloaded from online sources, and it was here that I discovered that 3D printing software wasn't as simple as I'd previously assumed. There are in fact 2 different file types used in 3D printing. The first file type provides coding for the structural design of the object that is going to be printed. The most common file format for this is SDL. The second file type provides coding for the object to be converted from the STL model into a series of very thin cross-sectional layers. This is done by Slicer software, which generates G-code, the programming language that provides commands so that the printer knows where to deposit material and how much to extrude. Users can adjust various settings within the slicer to optimize the print, including layer height, infill density, support structures, and print speed. There's quite a few software programs for generating G-code, with the two most popular being Cura and Prusa Slicer. Following instructions from the website Instructable, I selected from Thingiverse a simple pen holder to print and downloaded the STL files plus some PNG file images of the object. Then I downloaded the Prusa Slicer software from prusa3d.com, which turned out to be not particularly user-friendly, but I managed to get to the point where I downloaded and sliced my file, then uploaded the G-code to the Ender SD card. When I loaded the file to print, an image of a different object came up on the user interface, but I took the chance and set the file to print. All went well for the run, except for the fact that I had neglected to note the print time in the Prusa screen, which turned out to be nearly 15 hours. Then later it became 18 hours, so I made a ruthless decision to stop the printing, as this seemed a little ridiculous. I had proved that I could create a G-code file, and that was all I needed to know at this stage. A quick search on YouTube produced several files with links to DJI drone accessories, most of which were free via websites such as Thingiverse and Cults3D, while some had a download fee. This included a carry case suitable for my Mini 2 drone, although at $3.87 it wasn't that expensive. I also found a couple of free models, so I decided to try one of those first. But then I stuffed up. I decided to swap the filament from plain grey to a rainbow of green and gold, but in trying to remove the old filament, I managed to snap it off with the filament still inside the feed tube. A minor panic ensued until I phoned the friend who'd given me the printer, and he reassured me that all I needed to do was feed the new filament into the line. I downloaded the files for the top and bottom of the drone case from Thingiverse and dropped them into Prusa Slicer, generated G-code for their print instructions, then transferred the files to the printer. The base piece would take about 14 hours to print, but I set it going and periodically checked on progress. In the early hours of the next morning, I staggered out to the garage in my pajamas to check on progress to find it had finished. It took quite a while to ease the model off the build plate sheet, and, despite taking great care, some of the bottom layers stayed stuck to the sheet. Online research revealed that isopropyl alcohol would clean the plate, so I headed into the J-Car shop to buy some. However, along with a bottle of ISA, I was sold a myth. The ISA did nothing to clean the plate, and I had to chip away the worst of it with a scraper. But nevertheless, I was thrilled. The bottom of the case fitted the shape of the Mini 2 drone perfectly. My next task was to print the top cover for the drone case. I loaded the files and started the print, but it didn't look right. The outline was the correct shape, but the sides looked as if they wouldn't be deep enough. I watched as the whole case filled with a web of lines. I was deeply puzzled, but there was nothing I could do while it was printing, except to periodically check that the machine was still operating. However, when I came back after dinner, it dawned on me that the infill was the supporting structure which would hold the sides in place during the build process, and I had put these instructions in as an operation command in the job request. The web of crosshairs would need to be removed when the job was finished. Once again, the print took some 15 hours, but at the end I was elated. My 3D printed drone case was absolutely perfect. However, when I researched how to print a case for my Mavic 3 drone, it quickly became apparent that it wouldn't be possible to print one in a vertical position, and that my Creality 3D printer wasn't big enough to print one in a horizontal position. When I mentioned the problem to the friend who'd given me the printer, he offered to print the case himself on one of his bigger 3D printers. He very kindly did this for me, and a week later presented the case to me. Unfortunately, the design that it used must have been for an earlier model of the Mavic 3, because the base of the case turned out to be too small for my drone. Another week later, he produced a second case which he'd set to print 8% bigger than the first one and which turned out to be a perfect fit. The Creality Ender 3 V2 Neo printer sells for $329 at my local JCar store, while my friend had kindly also given me 3 spools of PLA filament to use. They usually retail for between $20 and $40 depending on quality. A 1-litre bottle of isopropyl alcohol cost me about $12 at JCar. Join me for my next episode when I recount my experience having acting lessons at a local thespian academy and find out if I could have been an actor in my youth. For more information about living your own unlived life, if you go to my website, you can download a copy of my free book, Living Your Unlived Life, Finding Contentment by Honouring Your Dreams. And if it's your thing, you could like this video and subscribe to my channel.